calls. And there comes the term socket. Okay. So what are sockets? Sockets are working as a communication medium between the applications. So different users are working on particular application, and we have to communicate from one point to another. This is working through sockets. So or sockets makes possible a communication between the communication through the applications. Okay. And mainly we are using the architecture. For the socket programming, we have the architecture client server architecture. So client initiate the communication, server respond to client request. That is the possibility of networks. We have a server concept and several clients are communicating to the server. So client initiate communication and server respond to the client request. And there comes the connection between client and server. So we are making a request on a particular application. We have to get the result. So we are using FTP, file transfer, email. We are using SMTP with the email. So we have to send some mail. So there is a response from the server. We are sending something, and to support that sending, to support the application, we have some response from the server side. Okay. So this client server communication is done through the concept of socket. Okay. And already we told the socket programming or the interaction between the with the transport layer, network layer, and data link layer are through kernel space. So we cannot directly interact with the kernel space. So we are interacting to the kernel space through various system calls. Okay. So these are the set of system calls to get the service from TCP/IP protocol stack. So we are mainly here in this session, we are mainly following TCP concept, transmission control protocol. Okay. And what are the system calls using in TCP socket programming or the socket programming in the kernel space? What are the system calls? And here we are terming one is socket system call and a bind system call, listen, accept, receive, send, and close. Okay, these are the important system call relating to TCP/IP. And client side we have socket, connect, send, receive, and close. Okay. These are the system calls in client server programming or socket programming. And socket actually, what is socket? I not define the socket. What is socket? Socket actually is a binding of network address and the port address. Port address for every application have separated port address. Or in order to use an application, we have to set the corresponding port. Then only we can work with different application. So, but in order to work with the application, we have to connect this application to network. Application to network. That is the binding happening here. And the port number bind with the IP address. We are terming it as socket. So socket is actually a binding of port number, application and network, or application connecting to network. In order to work with the application, we need network. So we are connecting the port number related to a particular application and with the IP address of the particular network we are following. So that particular binding point is known as sockets. I'm not giving the actual definition. It is the meaning of the socket. So it combines or it binds both port application and corresponding network. And in order to work with the socket, we have to use this set of system calls, which are in operating system kernel. So here mainly we are following Linux. So it all related to Linux based programming. We are following Linux based programming. And socket types. What are the different socket types? In general, we are only mentioning two types of socket. One is TCP and UDP socket. What are the difference? We have already some idea on difference between TCP and UDP. TCP, transmission control protocol, UDP, user datagram protocol. So TCP is a connection oriented one, UDP is a connectionless. Thus, we can tell TCP as a reliable connection, UDP as an unreliable connection. So, corresponding to these differences, we have two types of socket. Basically, we have two types of sockets. One is stream socket, another one is datagram socket. So, stream socket is connecting with the TCP and the datagram socket connecting with the UDP. Transmission control protocol, we have a connection. So, through the connection, we are send the data as a stream. And in unreliable, there is no connection. We are sending as a datagram. So, according to that, we are naming the sockets also, stream socket and datagram socket. Besides these two types, we have another case also there, that is known as raw socket. So, raw socket bypass the network applications. We have specific usage for the raw sockets that we will discuss later. Okay. Another part is there. There we use the raw socket concept. So here we are only mentioning stream socket and datagram socket. So the idea is sock stream. Stream socket is defined as referred as sock stream, and datagram sockets are referred as sock underscore dgram. That is datagram. Okay. So mainly corresponding purposes we are using stream socket and datagram socket. Mainly TCP based application we are following sock stream, and for the UDP based applications we are following sock dgram. And socket is an endpoint for communication. That is the definition part. Socket is an endpoint for communication. So communication starting at the socket and ending at the socket. Okay. So ending and starting at the socket. That is particularly defined as socket. IP address plus port number identify socket. To identify a socket, we need IP address, both IP address and port number, and address, network address needed, and a port number of the application needed. And so this is the case. Socket is identified by IP address, port number, and protocol. And elementary TCP socket functions. In order to maintain or in order to work with the TCP socket programming, we need these functions. These functions are defined as various system calls. Defined as various system calls. Any problem with the slides? Hello?
Sir, കുഴപ്പമില്ല കേട്ടോ, കണ്ടിന്യൂ ചെയ്തോ.
Okay. I have some problem with the slides, that's why I asked. Okay, elementary TCP socket function. Socket, connect, bind, listen, accept, send, receive, and close. Okay. And the first function we are dealing with is socket function. So it creates a socket endpoint. So endpoint means either a starting point or an ending point. So in client part and server part, we have to use this socket function. Okay, to create a socket endpoint. So syntax is int is a return value, an int value. So we have the structure. Syntax is int socket, int domain, int type, and int protocol. So actually we have the domain. Domain means communication domain. There are different domain representation for IP version 4, IP version 6, and any different networks we are following, there are different communication domains. So we are following mainly in these sessions, we are following IP version 4 addresses and networks. So the domain is AF underscore INET. So we are using communication domain as AF underscore INET. Okay. And type of the socket. So we have to mention either SOC stream or SOC diagram. If we are using raw means SOC underscore raw. Here SOC underscore stream for the TCP, SOC underscore diagram for the UDP cases. And protocol specifies protocols usually set to 0. So in various protocols we are applying the socket concept. So we are not mentioning. We can give the protocol number either, or we can set it as 0. That is the concept. So in order to build the socket, in order to create the socket, this is the mechanism. So we have a socket ID. India is providing the socket ID. It responds the socket ID. So we are getting a socket ID. We are creating a socket means we are creating a socket identifier. So using the socket identifier, we can refer the socket. Okay. So India's it's the socket ID equal to socket domain type protocol. So the as a whole we will get the return value is the socket ID. So using the socket ID, we can refer particular socket. Remember, communication domain we are following is AFI net for the IP version 4 protocol. Okay, and if AFI F underscore inet 6 is the IP version 6 communication domain. Okay, and type is either a stream socket or datagram socket. We are following. And then the raw, another concept, raw socket is there, we will mention later. In the protocol, we can set it as 0. And that is the socket creation. And next one is, we have okay, struct sock address in. We can later we can refer the bind protocol. Okay. In order to use the socket concept, we have
PPT change ആവുന്നില്ല ട്ടോ. PPT.
Okay. അത് എന്റെ സിസ്റ്റത്തിൽ ചെറിയൊരു പ്രശ്നം ഉണ്ട്, അതുകൊണ്ടാണ് തോന്നുന്നു. ഓക്കെ, അപ്പൊ ഓക്കെ ആണോ? ചേഞ്ച് ആവുന്നുണ്ടോ? ഓക്കെ ആണ്, ചേഞ്ച് ആവുന്നുണ്ടോ?
ചേഞ്ച് ആവുന്നുണ്ട്.
ഓക്കെ അത് ഓക്കെ. So we have some more information on the sockets. So we have to use a structure, struct sock address underscore in, which is referring the family, SIN family, that is AF underscore INET for the IP version 4 protocol. Then address, we have to provide the source address. Normally we can give any address, choose any local address, or we can provide the value as in address underscore any. That means that will refer any address. Okay. So in address means it will choose local address. Clear? Or we can directly refer loop back address or any other address with some function. Again, we have to refer or we have to convert that address into text to string and string to text, etc. Some definition needed. So here we have to refer it as in address any, and sign port number. Just to give the port number. Okay. And here we have to use some functions like h2ns or h2nl, etc. There are some functions are there to convert the port number from host byte order to network byte order. Host byte order to network byte order. So we are defining a structure sock address underscore in server address to refer the server part. Okay, struct sock address underscore in server address, and we are providing a port, one port number, and then the family as AF underscore INET, and server address is given as in address underscore any, that will refer any local addresses, and we have to assign server address dot sin underscore port as h2ns, that is already given host byte order to network byte order. So what is network host byte and network byte order? Mainly we have two systems to store the addresses in memory. That is little endian and big endian. No, I am not going in detail, just giving the reference. Okay. Little endian system and big endian system. So the little endian, the mechanism is the higher order register, lower order values are putting in the memory first. Okay. 0, that is the rightmost. Okay. LSB details are storing memory first, then following the other part. And big endian in the reverse order. Okay. The rightmost last. Okay, that is the concept. Okay. And I'm not going in detail for the little endian, big endian, but this problem may affect the data transfer. Okay. Because in the network byte order and host byte order may different. We are passing through different networks. So host byte order, we are using one mechanism, network byte order may use another mechanism. So in order to make the compatibility between the order of bits we are sending, we are using the functions like H2NS. So host to network, or in reverse order. There are several functions related to H2 concept, or this H2L is there. This is host to network in short int, or H2NL means it is the long int format. So whatever format we have to make it, in order to convert that, we are using the functions. So port number should be compatible to compatible to the data transfer. Okay. So in some case, host byte order and network byte order may differ. So in order to make the compatibility, we are using such a transfer function. That is the usual procedure. Okay. And assume a communication from little endian to big endian system, or vice versa. Okay. So that is why we are making it order using the functions. Okay. H2N or N2H is there, or H2NS is there, H2NL is there. So the various different category for the conversion function. Okay. And host byte order, network byte order, and the host byte order. So making it compatible. That is the aim for this usage of this function. Okay. That is the first part. So we have the details of socket, and we have the struct socket address underscore in, and then we have the little endian, big endian transfer, or compatibility between the host byte order and the network byte order, and then we are moving to the next function, that is known as byte function. Okay. So I think you got the basic idea. You can ask any in between. You can ask any query. Okay. And next is bind function. So associate socket with the IP address and port. So we are making a association between IP address and port is through the bind. So initially we are creating the socket, and then we have to bind between IP address and the port. The bind function assigns a local protocol address to a socket. The protocol address is the combination of either 32-bit IP version for address along with the 16-bit TCP or UDP port number. So address size is 32-bit for the IP version, for 16-bit for the TCP or UDP port number. That is the usage. 128-bit is now we are not following with the IP version 6 address. And we have an including header file sysbar socket.h, which contain the details. Okay. And int bind and representation int bind, return type is int, and we have to provide the status. Okay. and we have the sockfd. Sockfd actually socket identifier. We already created from the socket system call. There is a return value for the socket system call, that is the socket identifier or file descriptor, and that is the first part. Then we are providing the sock address, the address of the, we are providing the address. What address? For the server concept we are following the address and the address length, whatever the length we are following. This is the bind system call definition. Okay, and it returns 0 if okay, -1 an error. That means if the binding is successful, it returns 0. The second argument, my address, is a pointer to protocol specific address. Third argument, address length, is the size of this address structure. Okay, my address is protocol specific address. That is the mainly this client server communication. So the IP address, IP is the protocol. So protocol address, specific address, and the address length is the size of the address structure. Okay. Now, next system called listen and accept a socket connection. So there comes the difference between TCP and UDP. TCP is a reliable connection, UDP is an unreliable connection. Or TCP is in TCP we have to establish a connection. In UDP no such connections are establishing. So in TCP we need this two system calls such as listen and accept. There we are accepting the connection. And struct socket address underscore in client address. We are providing the client part, client address, and making a listen. Listen means listen for the connection. Listen for the, it is waiting for the communication. Okay, and sockfd is the created socket ID, and the 5 is the possible connections, number of possible connections. Here we are giving 5 only. Okay, so 5 means 5 possible connections are there, or we can 5 connections are possible in this communication. And the client length is size of the client address. So we need the client address in the client part, and client length is the size of the client address. And new socket ID. So we have to create a new socket at the client part, and that ID given for the accept. Okay, accept is the system call for accepting the connection. Accepting the connection. So new socket FD we are creating for establishing the connection. Okay, accept socket FD is already created socket ID. Then we are providing the socket address for the client. So which client is connecting to establish through this particular socket, that is the new sockfd, and accepting the connection to that particular socket with the ID sockfd, and the address of the connector is client address comma client length. So in client part we have to provide the client address and the client length, and we are creating a new socket at the client part. Okay. The server needs to announce its address remains in the open state and waits for any incoming connections. The client only opens a connection when there is a need for data transfer. Okay. Connection is initiated by the client. Mainly, we are creating the programs and server execution, then client execution. At that time, the connection initiation takes place, and server is receiving the connection. Okay. Okay. The listen function is called only by a TCP server, and it performs 2 actions. Okay. So there comes the accept part from the client, and then the listen part at the server side. So an accept part from the connection client means it initiating the connection. So listen will listen the, or it will accept the case. Okay, listen will listen at the server part. So it performs listen function convert an unconnected socket into a passive socket, indicating that the kernel should accept incoming connection request directed to this socket. when a socket is created by the socket function, it is assumed to be an active socket. That is client socket that will issue a connect. Okay. So client socket issuing the connect and the server socket just receiving the case. After receiving means it becomes passive for the communication. The function is normally called. So initially active, and when communication started means it becomes passive. This function is normally called after both the socket and bind functions and must be called before calling the accept function. That is the order of the communication. Okay, server getting the accept, and it will listen the case, and that connection establishing takes place. That is initially socket creation. I have we have one diagram also. Okay, this is the part. So we are making the server part. We are creating the socket and bind the socket, and client part we have the up to listen. Then the client part we have to connect it to server, and that will be accepted through listen. That is the accept part. After listen, we are accepting the client, and then the data transfer will takes place. So client initiating the connection, starting the request, and that will be accepted by the server, and that means it is ready for the communication. It is ready for the data transfer. Okay. Okay. Now, for the this is the initial part. So we have initially we have the socket class socket. We are creating the socket and both side, and then we have the connect part initiated by the server, then binding part, then listening part, and the accepting part. Up to this part, it is in the server side, and connect socket, bind, listen, accept, and connect part from the client side. Okay, so this will establish the connection. So connect, make a request, initiation from the client side to the server, and server listening the case, and finally it is accepting. It is the three-way handshaking procedure. So executing connection, connect will make a request, bind and listen, accepting the connection or receiving the connection request, and accept system call will establish the connection. Okay, that is the three-way handshaking. Okay, and after that we have to transfer the data between client and server. One is sending and other is receiving part. Okay, send system call and receiving system call. In socket stream, that is TCP sockets, we are using read and write mechanism. So for the send and receive, we are using read and write mechanism. Read to the new socket already created at the client side, and write, we have to send the data. We have to accept the data from the server. So read will send and write will accept the data. And for read and write system calls, then for the datagram concept, we have receive from and send to. Receive from and send to. And in datagram, there is no connection establishment. That means only socket system call, then the bind system call is enough. Okay. And there is no connection establishing between UDP clients, UDP client and server. But in TCP, we have to use all those system calls such as listen, listen, then accept and connect. Using these system calls, they are establishing the connection. Okay, that is the difference. So in UDP concept, we are using the data transfer function as receive from and send to. Okay, and receive from where we are receiving. So SOC referring the SOC ID, then the buffer part, then the size of the buffer. Okay, and from which address it is receiving. That is we have to given here. Send to means again we have to give the ID and then the message and then the size of the message. Okay, then a flag value. Then you have to give the address from where we received the, or not from where, to which address we have to send the message. Okay. Okay, in server side, socket, bind, listen, and accept. Client only socket and connect. These are the system call mechanism we are following the workflow in client server mechanism. In server part, we have to use socket system call, bind system call, listen, and accept system call. In client side, we have socket and connect. So initially we are creating socket and binding. After binding, it make a listen. Listen means it is waiting for any request from the client side. Okay, and connect will initiate the request, and server accepting the connection through accept system call. Okay, so this is the establishment of connection in TCP client server. Okay. I think we can discuss the program related to TCP client server. Okay, so this is the program in our syllabus. So that is why the same program is given. Sending metrics to server. Okay, server identifies type. So that is the mechanism. So here the program, I think in the syllabus is given as, okay, this is the program, client server communication using TCP. The client input an integer n and create a square matrix of order n by populating the matrix with random numbers in the range. It then send the matrix to the server, which identifies the matrix type, upper triangular, lower triangular, diagonal. Server then informs the type to the client, which it prints. Okay, that is the program in TCP IP communication. Okay, and so initially this is the usage. The client part, input integer, then n by n matrix will be created and fills the value or reading the value at the client side, then send it to the server. Okay, that is the part with the client. And in the server part, we have receiving the matrix, identifying matrix type, upper, lower diagonal, send the result back to client. The client prints the result. Okay. And this is the overall architecture for the program. Input n. Here create socket. Initially, server side will create a socket, bind a socket and listen. And in client side, connect it to server. And here the listen part. Then the communication takes place. Okay. Finally, close the socket. So these are the header files. Mainly stdio.h, stdlib.h, different for different applications. Std mainly for the, I think in OS, the kernel functions are held by or controlled by unistd.h, and inet.h mainly for the network applications. Okay. And first one is create a socket. Okay, create a socket. Whether we can do the program in parallel or we have to show the program in parallel. Program parallelly കാണിക്കണോ?
വേണം സർ.
പ്രോഗ്രാം മുഴുവൻ കാണിച്ചിട്ട് എക്സ്പ്ലനേഷൻ പറഞ്ഞാൽ മതിയല്ലോ അല്ലേ? ഓക്കെ, കാരണം ടൈപ്പ് ചെയ്ത് സമയം എടുക്കും, അതുകൊണ്ട് പ്രോഗ്രാം എടുത്ത് കാണിക്കാൻ, അതിനുശേഷം അതിൻ്റെ കൂടെ തന്നെ എക്സ്പ്ലനേഷൻസ് കൊടുക്കാം. കാണാവോ? പ്രോഗ്രാം കാണാവോ?
യെസ് സർ, കാണാം.
Okay, okay. So initially we are going with server side. Okay. So server side we have server side we have starting with wait. Server side we have starting with socket creation. Create the socket. Okay. Create the socket. So we have the return value socket ID. Socket ID equal to socket. Socket is the system code. Then is the family. Okay, address family AF underscore INET. That is for IP version 4. Then we are applying TCP, transmission control protocol. Okay, so socket stream we are naming the socket. Then this value is 0. Okay, that is already defined. Then next is and we are referring the socket address. Okay, struct socket address underscore in and in server details. So there server is the name, structure is mentioned, server dot sin underscore family, that is AF underscore INET, it is an IP version for address, and server port H2Ns. H2N means host to network in short unsigned int format. This is the port number, and this is the address part. Address in, address any. Okay, we can provide any address. In address any is enough. Or we can refer the address directly. That is also possible. You can give any loopback address or any other address also. It is possible. Okay. So this is the case. And next is bind part. Bind socket. Bind socket. That is the third case, third step. Then the bind socket. Bind socket contain bind sockfd. Okay, sockfd means already created socket ID, that is sockfd. And then the struct sock address. So server address to be mentioned. Okay, struct sock address, server address to be mentioned, and size of the server address. Server is the address. Okay, we already defined struct, that is a structure. So struct sock address and the size of the address. Okay, that is mentioned in the bind. So we are binding that socket to that particular connection. That is the part. We are creating an endpoint. That is the binding part. And then we are calling listen. Listen sockfd. That is the socket created, and at most 5 connection. You can provide any other number. So here we are expecting mostly five connections only. So up to this point, okay, we are listening for the client part. Okay, we are listening for the client part. We are listening for the client part. Now we are moving to the client. Now we are moving to the client. And in client also we have to mention the server address. Okay. Then sockfd. Okay, the same. We are creating the Okay, we are creating the server. So we are creating the socket. Then we are mentioning the family and all the details. Okay, here we just given us inet address. A loopback address is given because client and server are working the same case. So we are mentioning the address as loopback address 127.0.0.1. That is the client address. So it's a loopback address. Okay, and we are invoking connect system call. Okay, so connect system call, we have the socket ID, then the server address, size of the server, connecting to the server. That is the meaning. So we are requesting a connection to the server. This is the connect part. Okay. Now again we are moving to the server part. So server up to the point listen. We are maintaining the listen. Okay, listen case. And after the listen, we have to accept it. So for the accepting the request, we are using a new socket ID. Okay, new sock. ID will be different. Socket only created. ID will be different because further connections are there, means we have to use different ID. Okay, different connections are there. So we have to accept with the different ID. We cannot maintain with the same socket ID. So we are using a new socket ID. Accept that connection. There is a request from the client part and we are accepting the connection. Okay. So this is up to this, the handshaking procedure completed. This is up to the handshaking procedure. So initially in the server part we are creating the socket, and client part also we are creating the socket, and in server part we are mentioning the address details, and then mentioning the we are creating the socket, then binding the socket to the address, then we are maintaining the listen part. Okay, and listen part means we are waiting for the request. Okay, that is up to server part. Then the client part, we have the connection request. Okay, all other details are the same. Socket creation done. Then the details are specified. Then the connection request received from the client, and server will accept the case. Okay, server will accept the connection with the new ID. So this is the procedure up to which the handshaking procedure completed, the connection will be established. Okay, now we have send and receive system call. We are using send and receive system call for the TCP protocol, and the send, syntax of send. So here the logic starts. Okay, logic is starting here. And the logic is starting here. Sending part. So logic initially size of the matrix. Then we are using a random function that is connecting to related to program. In our lab it is given as random number, or otherwise you can just mention the n value and just read the matrix. That is enough. Okay. And in order to generate the random, we are using the srand function. Okay. And then the matrix is generated. Matrix is generated up to this case. Okay. Then sending the details to server from the client part. Sending means send socket. Okay, that is from the client part. Send with the socket ID. Okay, we know about the socket of the socket ID. So using that socket, we are communicating to the server. So and n value, that is first of all we are sending the limit. So n value sending and size of the address of the variable we are sending, initially address location sending, then size of the value, then putting a flag value 0. Okay. Now sending the matrix. Send matrix, then size of matrix we are sending. Okay. And in the server part, we are receiving what is sent by the client. Okay. Server part, we are receiving using RECV, new SOC, the same procedure. Initially, the n value will be received, then the matrix will be received. Okay. Then the logic will be applied. Then whatever the logic to find the triangular, upper triangular, lower triangular, and diagonal matrix. Okay. Upper triangular, lower triangular, and diagonal matrix. So the logic will be written. And after finding, we have to make it, result should be as a string that is given in the syllabus. So we have to make it a string to give the result. Okay. And result generated, and finally sending the result to the client with the new ID. Send new SOC. Okay. Send new SOC, result, size of result 0. Result is an array. String is a string. So character array. So we are providing address means the name itself and size of result and 0. Send. Now the client part, we have receiving with the new again the old connection, receiving result and size of result. Okay, and result will be displayed. And after the send and result data transfer completed, the client will close the connection. So client will initiate the closing of the connection. Client will initiate the closing of the connection, and in server side we have to close both new ID socket and new socket and the old socket. Both will be closed at the server part. This is the ending of the connection. So we initially establishing the connection and finally closing the connection. In between we have the data transfer. And once again, in server part we are initially creating the socket, then binding the socket to the address. Okay, creating the socket, defining the address, binding the address to the socket. Okay, then initiating a listen function call, system call, and listen call means it is waiting for the request from the client side. And then in client side, again we are generating the socket, defining the address, and make a connection request. Okay, and in server side, the connection request is accepted by the accept system call with a new socket ID. Okay, and that means connection established. And after the connection established, the client will start the logic. Okay, whatever the things it has to read, it initiate the logic and sending the details to server, and server receiving the details and proceeding with the logic. And what is the result? The result is sent to the client. This is the operational part. And after receiving the result, the client making the closing part. Okay. Because server not closing, because server is waiting for the connection from everywhere, anywhere. So server is not closing, client is closing. So after client is closing, the server initiate the closing of the connection. Okay, this is the client server programming in using TCP mechanism. Any doubt regarding this or any clarity needed? Clear ആണോ? ഓക്കെ, നിങ്ങൾ ഓൾറെഡി പലരും സോക്കറ്റ് പ്രോഗ്രാമിംഗ് ചെയ്തവരായിരിക്കും. അപ്പോൾ അവർക്കത് വളരെ ഈസി ആയിരിക്കും. ഞാനിത് ബേസിക് സ്റ്റെപ്സിലാണ് പറഞ്ഞത്. അതിലെന്തെങ്കിലും ക്ലാരിറ്റി വേണമെങ്കിൽ ചോദിക്കാം. കാരണം നമുക്ക് പ്രോഗ്രാം അവൈലബിലിറ്റി അല്ല, നമ്മൾ എങ്ങനെയാണ് TCP-യിലൂടെ എങ്ങനെ എസ്റ്റാബ്ലിഷ് ചെയ്യുന്നത്. ലോജിക് ഏതും ആകാം, കുഴപ്പമില്ല. ഇനി ലോജിക് വി ക്യാൻ ഇംപ്ലിമെന്റ് ത്രൂ ദി പ്രോഗ്രാമിംഗ്. ഓക്കെ, ക്ലിയർ ആണോ? പ്രോഗ്രാം എക്സിക്യൂട്ട് ചെയ്യണമെങ്കിൽ നമുക്ക് ചെയ്യാം. സോറി, അത് ഇന്നലെ തന്നെ റാൻഡം ഫംഗ്ഷൻ മാറ്റിയിരുന്നു, അതുകൊണ്ടെന്തോ ചെറിയൊരു മിസ്റ്റേക്ക് വന്നതാണ്. നോക്കാതെ എന്തോ ചെറിയൊരു പ്രശ്നം വരുന്നുണ്ട്. റീഡ് ചെയ്യുന്നതിൽ എന്തോ കുഴപ്പം കാണിക്കുന്നുണ്ട്. റാൻഡം ഫംഗ്ഷൻ ആയതുകൊണ്ടാണ്. നോക്കാം, ചെക്ക് ചെയ്യാം. ഓക്കെ, ഇനീഷ്യലി അതൊരു ഔട്ട്പുട്ടായിട്ട് വന്നിരുന്നു, പക്ഷേ എനിക്ക് ചെറിയൊരു ഓക്കെ. ഇങ്ങനെയാണ് ആൻസർ വരുന്നത്. എൻ്റെ ഓർഡർ ഓഫ് ദ മെട്രിക്സ്, ദെൻ മെട്രിക്സ് റാൻഡമായിട്ട് ജനറേറ്റ് ചെയ്യുന്നു, ദെൻ ഗെറ്റിംഗ് ദ റിസൾട്ട് മെട്രിക്സ് ടൈപ്പ് നോർമൽ മെട്രിക്സ്. റാൻഡം ആകുമ്പോൾ നമുക്ക് ട്രയാങ്കിളൊക്കെ കൊടുക്കാൻ ബുദ്ധിമുട്ടായിരിക്കും. അപ്പോൾ വേണമെങ്കിൽ നമ്മൾ ലാബ് ചെയ്യുമ്പോൾ യു ക്യാൻ ഡു വിത്ത് മാനുവലി യു ക്യാൻ എൻ്റർ ദ മെട്രിക്സ്. ഓക്കെ, ഇത് റാൻഡമായിട്ടാണ് ഇതിപ്പോൾ ജനറേറ്റ് ചെയ്തിരിക്കുന്നത്. അപ്പോൾ റാൻഡം മെട്രിക്സ് വന്നു, അതിൻ്റെ റിസൾട്ട് സെർവർ എക്സിക്യൂട്ടഡ്. ഓക്കെ, ഇതാണ് പ്രോഗ്രാം. ഒന്നാമത്തെ പ്രോഗ്രാം, ക്ലയന്റ് സെർവർ പ്രോഗ്രാം യൂസിങ് TCP. ഓക്കെ ആണോ? ചെറിയ കോഡ് പ്രശ്നം വന്നുകൊണ്ടാണ്. ഓക്കെ, അപ്പൊ അതിന്റെ മെക്കാനിസം ഓർമ്മിക്കുക. ആദ്യം സെർവർ സൈഡിലാണ് ചെയ്യുന്ന കാര്യങ്ങൾ, ദെൻ ഡു വിത്ത് ദ ക്ലയന്റ് സൈഡ്, സെർവർ ആൻഡ് ക്ലയൻസ് എക്സിക്യൂഷൻ, അതിന്റെ ബേസിക് സെറ്റപ്പ് കണക്ഷൻ എസ്റ്റാബ്ലിഷ് ചെയ്യുന്നു. ദെൻ transfer data from the client side to the server, and server receiving the data with new socket ID, and it proceeds. Okay, it proceeds the logic, and then finally reply back to the server. Okay, and ഇതിപ്പോ നമ്മളിപ്പോ നോർമലി ഇത് സിംഗിൾ കൺസെപ്റ്റേ പറഞ്ഞിട്ടുള്ളൂ. ഇനി എക്കോ സെർവർ എന്നുള്ള കൺസെപ്റ്റ് ഉണ്ട്. എക്കോ സെർവർ എന്ന് പറഞ്ഞാൽ യു ക്യാൻ കണ്ടിന്യൂസ്ലി യു ക്യാൻ ഡു ദ കമ്മ്യൂണിക്കേഷൻ. ഇറ്റ് ഈസ് എക്കോ സെർവർ. വാട്ട് ആർ ദ തിങ്സ് ഫ്രം ദി ക്ലയന്റ്, ദ സെർവർ വിൽ റെസ്പോണ്ട് കണ്ടിന്യൂസ്ലി. ഓക്കെ, അപ്പൊ അത് ഡിഫറെന്റ് ആയിട്ടുള്ള ലോജിക്കാണ്. അപ്പോൾ ഇനിഷ്യലി നമ്മൾ ടി സി പി യൂസ് ചെയ്യുന്നു, ആൻഡ് വി ആർ ഡൂയിങ് ദ സോക്കറ്റ് പ്രോഗ്രാമിംഗ് എന്നുള്ളതാണ് ഈ കൺസെപ്റ്റിൽ പറഞ്ഞിരിക്കുന്നത്. ഓക്കെ ഓക്കെ, അങ്ങനെയാണെങ്കിൽ നമുക്കൊരു 5 മിനിറ്റ് ബ്രേക്ക് എടുത്തിട്ട് അടുത്ത UDP-യുടെ കേസ് പറയാം. ഓക്കെ, ഇത്തരത്തിൽ പറഞ്ഞാൽ പോരെ? ഇങ്ങനെ പറഞ്ഞാൽ മതി അല്ലെ? എന്തെങ്കിലും കൊറിയോ കാര്യങ്ങളോ ഉണ്ടോ? ഫീഡ്ബാക്ക് ഉണ്ടെങ്കിൽ പറയാം. ഓക്കെ 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 5 മിനിറ്റ് കഴിഞ്ഞിട്ട് സ്റ്റാർട്ട് ചെയ്യാം. ഓക്കെ. Okay, can we start? I think we can start with UDP socket programming. Okay, so okay, the theory part. I'm not going in detail, just giving an overview only. Okay, so UDP actually it is a connectionless mechanism. It is an unreliable case. So the three-way handshaking is not there and unreliable, and it is a datagram protocol. So the socket type will be datagram, sock underscore dgram, and main applications are DNS, domain name system, NFS, network file system, and symbol network management protocol SNMP. All are under UDP. Okay, user datagram protocol. And this is the connection mechanism. Sorry, this is the connection mechanism. UDP client and UDP server. So some steps are not in TCP. Some extra steps are there for the connection establishment, but here there is no such case. But the same system goals are applying here also. So in UDP server part, we the socket creation first, then binding the socket to a particular address. Okay, that is the part in UDP. Then in UDP client part, UDP server part, and in UDP client part, creation of the socket. That is the only point we have to do. Okay, and then we are mentioning the addresses also, and then we are using the data transfer commands, that is send to and receive from. Okay, send to and receive from. Okay, so data request and data reply as such. Okay, initially client is sending some or starting some initiative, and by availing that, the receiver will respond. Okay, that is the case. And so these are the main function that socket and bind all are already explained. Here receive from and send to functions. Okay, and receive from both receiving bytes. That is why the return value given as size underscore t. So byte, the size of bytes, that is received and sent. Okay, return types. Okay. Now both return number of bytes, read or return if okay. Otherwise -1. -1 means it is error. So any problem with the function invocation, it will be it will show error. Otherwise, the bytes will be received. Okay, and receive from, receive from, then in the socket ID. Okay, sock FD. So the created socket ID, that is the first part. Then we have to provide the buffer size. Okay, buffer. Sorry, we have to provide the address of the data. Then size of the data. Then we are providing a flag, comma. Then the address, receive from where. So that address will be given here. Okay, from where. So that address will be given here. And the address length, it is similar to receive in TCP. And send it to. And here also we have the sock ID, then the buffer, okay, buffer value, then the size, okay, size, then the flag, then again the specified address and address length. Okay. So these are the information. Receive from and send to. Okay. Okay. Then here providing an echo client server information. Echo client server. Echo client server means whatever what we were received from the client is a response. Okay, that is the echo concept. And here we are providing the strict sock address. Okay, client address, server address is there, client address is there. Then socket creation. Okay, this is client server part. Okay, simple echo server part. Then socket creation takes place. Okay, here AFI net, that is IP version 4 is the family. Sock diagram is the type of socket. So it's a UDP, so datagram socket. Then initializing the addresses, server address, size of server address. Okay, and address family, and again any address, in address, any address can be taken here, hosted to network in long unsigned. Then server address port number, that is H2NS, that is port number. Okay, that is the part. Again we are defining the things. And bind, next is bind system code. We are binding the socket ID to the server address. Okay, this is the part. Okay, this is a function. We are using a function to apply the logic. That is the details given here. Okay, function echo or DG echo function. So what are the details there? Socket length, message, then length of client length. Okay, then receive from socket FD, message, maximum line. Okay, this is a receiving part. Server will receive the things. Okay, actual message, then the message size, size of the message, then flag 0, the client address, length of the address, and send it to sock FD message n. We are providing the size. Then send it to means we know the size, that is why given n. Here we don't know the size. So what is the capacity? Or we can provide the size of. We can provide the size of things. And here send it to. So we have to provide the client address. Receive from. Again we have to provide the client address. Okay, this is the part with the UDP echo server. And now the main function part, echo client. Client, again client, we have the referred inet. Okay, we are providing the address. Okay, then sock FD, socket creation, and we are calling a function DGCLI. Okay, and in DGCLI we have sent, we are sending to server. Okay, so send it to particular socket, and what is the message and size of the message, then server address and server length. Receive from, again socket ID, the message, size, then null. From where? Anywhere, only the server will send. That's why we are giving the null value. Okay, and this is the case. Okay, receiving message, whatever the things, and what is received, that will be put here, received line. So this is a UDP echo client and UDP socket programming. So here we are not making any connection, only creation of the socket and binding takes place at the server point, and in client only socket creation and just send it to and receive from. Both are the functions. These two are the functions used for data transfer. Okay. Okay, this is the function, and in our program, I think we can go for the program part. UDP gedit UDP to server dot c UDP to dot c. So UDP server and UDP client. Okay. The program actually client server communication using UDP. You are very good at communicating in the new generation English language with all sorts of abbreviations like TBH, IG, etc. Now design a client server application follows. Client inputs a new generation English sentence from the user and sends it to the server. The server then translates the received sentence to formal English and sends the translated sentence back to the client which it prints. Okay. അതാണ് ക്വസ്റ്റ്യൻ. നമ്മൾ അബ്രീവിയേഷൻ പ്രൊവൈഡ് ചെയ്തിട്ട് അതിൻ്റെ അബ്രീവിയേഷൻ എന്ന് പറഞ്ഞാൽ ന്യൂ ജനറേഷൻ അബ്രീവിയേഷൻ ആണ്. ഓക്കെ. IDC means I don't care, etc. That is an example. So client will send the short form and server will return back the full form. Okay. So here we are only listing 5 or 6 and only we got the result also for the same. Okay. Excuse me. Okay. So അതാണ് പ്രോഗ്രാം, അതായത് UDP സെർവർ ആൻഡ് UDP ക്ലയൻറ്റ്. ഓക്കെ. ഇവിടെ എങ്ങനെയാണ്? UDP സെർവർ ആണ്. സോ ഇവിടെ മെയിൻ ഫംഗ്ഷൻ we are creating the socket. Okay. Initially we are creating the socket. Socket is the socket creation. Okay, hereby creating the socket and address specified binding part takes place. Okay, so this is the server part. Then the client part, we are creating the socket. Okay, that is enough. Okay, and here creating the sentence. Okay, enter sentence. F gets buffer, size of buffer, and we are having the sentence. And the buffer is sent to server. Buffer, size of buffer. Okay, it's an array, character array. So address, buffer means address. Then size of buffer. Then socket address, server, size of server. And receive from again. So FD buffer, size of buffer. Okay. And the server part receiving the same. Okay, receive from. Okay, from the client. Client address is given. Client address is given. Here, size of client. Okay. Then replace. So we use the function. That is the logic part. Okay. And how we are that conversion will takes place. So that is the logic. Okay. TBH to be honest. Okay. IG, I guess, etc. So we are giving a word buffer value and returning the sentence, and finally send it to socket, then again keeping it in buffer, replacing the terms also buffer, size of buffer, and sending to the client. Okay, sending to the client. And after receiving the case, receiving the details, connection will be closed. Close using close. Okay, so this is the UDP client. Hello, hello, clear ആവുന്നുണ്ടോ?
Yes, sir. Yes, sir.
Okay, okay, okay. So this is the case. So here we have only UDP server creation, then the client creation. That is there. UDP server creation and client creation. Okay. I think we can execute the program. So GCC UDP server dot C to So this is a server part executed. Then the client part. Okay, so then the client part. Client part. Okay, providing sentence. Okay, TBH. Okay, TBH. Translated to be honest. Okay, then and server also we have to execute IG. I guess so. Already we are given some list. So according to that, the result will be obtained. So here it is a UDP mechanism, and in UDP mechanism, there is no connection establishing. We are only dealing with uh, socket creation and binding the socket at the server point and just sending the data. So that is data transfer. Receive from and send it to system call. So we are using receive from and send it to system calls. Okay, that is the concept with the UDP server. Okay, so now we have another case is IO multiplexing. Next is IO multiplexing. So the third, next section is IO multiplexing with the select and poll function. Select and poll function. So currently we just covered TCP and UDP socket programming, and this is the same programming mechanism we are following, but with some differences. So here we are using the multi. Okay. Here we are following the multiplexing approach. Uh, so what is multiplexing means? Actually, it is a concurrent server approach. So a server is established for some time, and various more than one connecting to that particular server. Okay, that is the case. A server is established initially, and it will there is request from more than one clients. So the problem is, if we are using the same TCP or UDP mechanism, one client is established a connection, all others will be blocked. That is the mechanism in a UDP or TCP mechanism. One connection established means it will block all other connections. So we cannot continue with the other connections. So how to manage more than one connection at a time? So that is what we are mentioning with this multiplexing approach. Okay, that is what we are mentioning with the multiplexing approach. So introductions, there are different models are there for the multiplexing concept, and IO models, various IO models are there, and we have to study two functions, select and poll function. Select and poll function. Select and poll function. How to use concurrent servers with the select and poll function. Okay. Okay. TCP client is handling two inputs, standard input and a TCP socket. When the client was blocked in a call to read, the server process was killed. Okay. Server TCP sends finishing to the client TCP, but the client never see finishing since the client is blocked. Okay, that's the case. Parallel communication. Sometimes it will be another client or in all cases it will be blocked. And multiple descriptors more than one. It has used the script. Client situation. Like, more than one process. Then discuss FTP, HTTP now, right? Different individually they are separated process. So they have, okay, okay. അത് എൻ്റെ സിസ്റ്റം ചെറിയൊരു ഇതൊരു അതുകൊണ്ടാണ് ഞാനത് അതുകൊണ്ടാണ് സ്ലോ ആയി പോകുന്നത്. വരുന്ന ഓക്കെ, ഇപ്പൊ ഓക്കെ അല്ലേ? ഓക്കെ
ഓക്കെ സർ.
ഓക്കെ, എന്തോ ഇവിടെ ചെറിയൊരു ഡിഫിക്കൽറ്റി കാണിക്കുന്നുണ്ടോ നോക്കട്ടെ. introduction part. In what are the occasions this type of concurrency came? So one is multiple descriptors. So multiple processes using the client. copy datagram. Okay.